Ever wondered why lemons are sour or why soap feels slippery? The answer is chemistry, specifically acids, bases, and salts. These chemicals aren't just in labs, they're everywhere, in your food, cleaners, and even your body. Understanding them is like having a secret decoder ring for the world around you. Acids, bases, and salts are the key ingredients in the global kitchen of life, each with unique properties. Knowing how they work helps explain everything from fizzy sodas to healthy crops. We'll break down acids, bases, and salts, show you how to spot them, and connect it all to your daily life. By the end, you'll see these chemicals everywhere and understand their secret roles. Ready for a journey into the awesome world of chemistry? Let's get started. Let's talk acids. You might have heard the word before, but what does it really mean? Acids are all around us, and they play a much bigger role in our lives than you might think. The word acid comes from the Latin acidus, meaning sour, a big clue to their taste. That sharp, tangy sensation you get from biting into a lemon or tasting vinegar. That's the classic mark of an acid at work. Lemons have citric acid, apples have malic acid, and vinegar is acetic acid, all giving that tangy flavor. These natural acids are found in many fruits and foods, making our meals more interesting and flavorful. But acids aren't just about taste. They're also important in science and industry, where they help create everything from medicines to cleaning products. When dissolved in water, acids release hydrogen ions, H+, which is what makes them acids. This release of hydrogen ions is a key chemical property that sets acids apart from other substances. This property explains their sourness and their ability to react with other substances. For example, acids can cause metals to fizz or help break down food in your stomach. Some acids are corrosive and need careful handling, but the ones in food are weak and safe. Strong acids can be dangerous, but the acids in your kitchen are usually mild and harmless. You'll find acids in soft drinks, carbonic acid, yogurt, lactic acid, and even your stomach, hydrochloric acid, for digestion. Without acids, our bodies couldn't break down food properly. So acids are everywhere, from your kitchen to your body. They're in the foods you eat, the drinks you enjoy, and even in the air you breathe. Chemically, they're defined by their ability to release hydrogen ions in water. This simple fact is the foundation for understanding how acids behave and why they're so important. They're key players in many reactions and daily life. From cleaning products to batteries, acids help power our world in ways you might not expect. Understanding acids is the first step in our chemistry adventure. Once you know what acids are, you'll start to notice them everywhere. Next up, let's meet their chemical opposites, the bases. Get ready to discover a whole new side of chemistry. Now let's meet bases, the fascinating chemical opposites of acids. While the word base might make you think of baseball, in science it means something entirely different. Bases are a special group of chemicals with their own unique set of properties and uses. Bases are often bitter to taste. Imagine accidentally getting soap in your mouth, and they feel slippery or slick when you touch them, like the smooth lather of soap on your hands. That slick, almost slimy feeling when you use soap. That's a base at work, reacting with the natural oils on your skin to help wash away dirt and grease. When bases dissolve in water, they release hydroxide ions, written as OH-, which is what gives them their characteristic properties. These ions are responsible for the slippery feel and the ability to neutralize acids. Bases can accept hydrogen ions or release hydroxide ions, making them the chemical flip side of acids. This is why acids and bases can neutralize each other in reactions. You'll find bases all around you, in everyday items like soap, baking soda, which is also called sodium bicarbonate, and in many cleaning products you use at home. Some bases, like ammonia and sodium hydroxide, are considered strong bases. They're powerful cleaners that can cut through tough grease and grime, but they must be handled with care. Bases are everywhere in your home, quietly working behind the scenes in cleaning, baking, and even in some medicines. They help keep things fresh, clean, and safe. To sum up, bases are bitter, slippery, and release hydroxide ions in water. They're essential for many tasks, From cleaning your kitchen to baking your favorite treats. Whether you're scrubbing a sink or baking cookies, bases are hard at work making your life easier and your home cleaner. But how do we tell acids and bases apart safely? Let's find out in the next section. Tasting or touching unknown chemicals is unsafe, so scientists use indicators to identify acids and bases. Indicators are chemicals that change color in the presence of acids or bases, like secret agents revealing a solution's identity. The most famous is litmus paper. Acids turn blue litmus red, bases turn red litmus blue. If there's no color change, the substance is neutral. You can even make indicators at home. Boil red cabbage for a juice that turns pink in acid and greenish blue in base. Turmeric is another. It stays yellow in acid, turns reddish brown in base. Indicators are a safe, reliable way to classify substances. Whether it's litmus, phenolphthalein, or kitchen chemistry, indicators make chemistry colorful and practical. They help us safely solve chemical mysteries. That's how chemists spot acids and bases without risk. What happens when acids and bases meet? It's a fascinating process that's at the heart of chemistry, and it's called neutralization. When an acid and a base come together, they don't just mix, they actually react with each other. Acids are substances that release H+ ions, while bases release OH ions. When these two types of ions meet, they combine to form water, or H2O, which is neutral. This reaction cancels out the original acidic and basic properties, making the resulting solution neutral instead of corrosive or slippery. The solution becomes something new and safe to handle. But the story doesn't end there. The leftover parts of the acid and base don't just disappear. They combine to form a salt, which is another important product of this reaction. The general formula for this process is acid plus base yields salt and water. This simple equation is behind many reactions you see every day, even inside your own body. For example, when you take an antacid to relieve heartburn, you're using a neutralization reaction. Antacids contain mild bases that react with the excess acid in your stomach, producing harmless salt and water, which helps you feel better and more comfortable. Neutralization isn't just a laboratory concept, it's a key part of everyday life, from cleaning products to the food you eat. It's a perfect example of how opposites can combine to create balance and harmony in the world around us. From the chemistry lab to your own stomach, neutralization is an essential process that keeps things in balance and protects us in countless ways. Next, let's dive deeper and discover what salts are all about. When acids and bases neutralize each other, they create water and a salt. In chemistry, salt means any ionic compound formed from this reaction, not just table salt. For example, mixing hydrochloric acid, HCl, and sodium hydroxide, NaOH, gives you water and sodium chloride, table salt. But there are thousands of salts, each with unique uses. Neutralizing sulfuric acid with magnesium hydroxide makes magnesium sulfate, Epsom salt. Different acid-base combos create different salts, used in baths, baking, and more. Salts are everywhere, in food, medicine, and industry. They're the solid products of neutralization, essential for life and technology. Understanding salts completes the acid-base story. Acids are vital in our bodies and industry. Your stomach uses hydrochloric acid to digest food and kill germs. In the kitchen, acetic acid, vinegar, preserves food and adds flavor. Citric acid keeps fruits fresh. Mild acids clean mineral deposits and rust in your home. In industry, sulfuric acid is crucial for fertilizers, detergents, plastics, and batteries. Nitric acid makes fertilizers and explosives. Hydrochloric acid processes steel. Acids help us digest, clean, grow food, and build our world. Their reactivity makes them powerful tools when handled safely. Acids are true workhorses, from your tummy to the factory floor. Bases and salts are everyday heroes too. Strong bases like sodium hydroxide unclog drains and make soap. Milder ones like ammonia clean glass. Baking soda, a mild base, helps cakes rise, neutralizes odors, and soothes insect bites. Salts are essential. Table salt preserves food, while others like ammonium nitrate and potassium phosphate fertilize crops. Calcium sulfate, gypsum, builds homes. Sodium carbonate, washing soda, softens water and makes glass. Even your nerves rely on salt ions to send signals. Bases and salts are everywhere, cleaning, building, feeding and powering our lives. They're indispensable for modern living. From kitchens to construction, their uses are endless. Chemistry's everyday superpowers are all around us. We've explored acids, bases and salts, chemicals that shape our world. Understanding their properties gives you a secret key to everyday science. Indicators let us safely identify them, and neutralization explains everything from antacids to fertilizers. This knowledge helps you decode food labels, understand cleaning products, and grasp environmental issues like acid rain. It's the foundation for more advanced science, connecting chemistry, biology, and geology. Science is about curiosity, asking questions and discovering how things work. By learning about acids, bases, and salts, you've taken a big step in your scientific journey. This knowledge empowers you in class and in life. Keep exploring the colorful, reactive world of chemistry, because science is everywhere, and it's awesome.